Hi guys, it's still Mr. Richard. We are on MAE 2201 201M May June 2022. So this module is for those who are doing intermediate and senior phase, right? As I've stated in our previous video that in this video we are going to work with question 3 and question 4. Question 3 consists of patterns, right guys? You may recall that there are different kinds of patterns. We have linear pattern, we also have quadratic pattern, we have geometric pattern in senior phase and intermediate, right? That's very important to note, right? If you're new to this video or if you're new to this channel, don't forget to subscribe. Press the red button and subscribe. Let's go. 1, 2, 3. There we go. Thank you for your support. Let's grow this community. Well, at question 3, we are told at 3.1, while sorting some beads, Sipho put 2 beads in the first jar and 4 beads in the second jar and 8 beads in the third. Kelly placed twice as many beads in each jar than Sipho. Yeah, right. What matters here is for you to analyze the situation. Let's start with Sipho. Yes. Um, what is happening here? Sipho, for Sipho guys, it's Sipho in the first jar he put 2 beads, right? We are told. In the second jar he put what are we told there? He put four beads in the second jar. So the second one, it's 4 beads. So right, the third we are told that there are 8 beads in the third, right? So what about Kelly? Okay, what about Kelly? Kelly placed twice as many beads in each jar than Sipho, meaning that it's 2 times of what Sipho put in the jar, right? So 2 times 4, 2 times 2, I mean, that will be 4. 4 times 2, that will be 8. 8 times 2, that will be 16. So, right, we have 2 patterns here for Sipho and Kaylee. So that's what you were supposed to write. That's how we are going to get 2 marks there. Then they said represent the information in a form of patterns, right? So for Sipho S, I will say for Sipho it will be 2, 4 and 8, right? For Kelly, so it's 8 here. For Kelly it will be 4, 8 and 16, right? So that's how you are going to work with such. Then determine the rule in each. Okay, now I'll show you the rule. So we are on 3.1.2. Let's put the rule into practice. All right, for Kelly, for Sipho, let's start with Sipho. Let's check, is it an arithmetic pattern or a linear pattern or what we call a geometric? Let's check. 4 minus 2, that will be 2. 8 minus 4, that will be 4. So it's not a linear pattern. Definitely it should be a geometric. Let's see. 4 divided by 2, it's 2. 8 divided by 4, it's 2. So that means we keep multiplying by 2. We keep multiplying by 2 to get the consecutive term. 8 times 2, that will be 16 if they wanted you to get the next term. So how can we get the general term? You may recall the general formula for, sorry for that, for geometric, it will be Tn is equals to A times R to the power of N. So what is our first term there? Our first term, it's 2. A, it's for first term. What about R? R is a constant ratio. How do we get the constant ratio? It's a constant ratio, it's term 2 divided by term 1. So it's going to be 4 divided by 2, which will be 2. So in this case, it's going to be 2 multiplied by 2 to the power of N minus 1. So this is the general term, or the rule for Sipho. Let's go to Kaylee. Well, at Kaylee, it's a similar ratio because 8 divided by 4 How many times do we have? How many 4s do we have in 8? We have 2. So how many 8 do we have in 16? It's 2. So similar, the ratio here, we keep multiplying by 2, we keep multiplying by 2. If they wanted you to get the consecutive term, you add up 4 times 2, that will be 8, 8 times 2, that will be 16, 16 times 2, that will be 32. So if they wanted you to get, if they want you to determine the rule in each pattern, so remember, Tn is equals to AR to the power of n minus 1. So what is the first term there? It's 4. The constant ratio, it's 2. So 4 multiplied by 2 to the power of n minus 1. So this is the general term. This is for SIPO, and this is for Kelly. So guys, you will get 4 marks for saying that. Right? Okay. All right. Let's go to 3.2 now. At 3.2, study the pattern given below. Let's analyze the pattern first. How many shaded block box we have here? It's 3, 4, 5. So we have 5, right? Here it's 3, 6, 7, 8. So we have 8 here. All right. The other parts 3, 6, 9, 10, 11. So we have 11. Okay. So how many for term 4? They said draw the next shape in the pattern. Let's see, is this a quadratic pattern, or is this a geometric, or is it a linear pattern? Oh, how did they come up to 8? They added by 3. 5 plus 3, it's 8. Plus 3, that will be 11. Right? So, okay. So 11 plus 3, that means term 4. For term 4, we could get, we will have 14. So what will we do here? We will be smart. Let's draw. Okay. Yourself, you should use a ruler there. Very important to use a ruler so that yours become smarter than mine. Mine, it's ugly. I know it's ugly. Okay. So I will continue from the one that has 11. Ne? So it's 3, 6, 9. Okay, 10, 11. Okay, 12, 13, 14. Okay. Yes, something like this. Yeah. So they are 14. They should be 14 that are shaded. So yours will be just accurate. Draw, use a ruler. It will be beautiful than mine. So remember, it's for preparation. Make sure that yours, use a pencil so that it becomes clear. It becomes clear. Now draw a table to represent the information given. So to represent this, let me draw my table there. So I'll say position here. It's position. Okay. Position 1. How many do we have at position 1? We have 5, right? So we shall place 5 here. At position 2, how many do we have? We have 8, right? So we shall place 8. At position 3, how many do we have? We have 11, right? Then at position 4, how many do we have? We have 14. Yeah, that's how you can draw the table. So it's position, then it's a term, right? Position of a term, and here it's a term. Term 1 has 5, term 2 has 8, term 3 has 11, term 4 has 14. So that's how you can. Now at 1.3, they want you to find a formula. How will you get the formula, guys? To get the formula, remember that we have 5, 8, 11, and 14. So the difference here, it's 3. 8 minus 5, it's 3. 11 minus 8, it's 3. 11 minus 14, that's 3. So this is our constant. I'll name it B. And this is our first term. I'll name it B plus C. Remember our constant, I said that it's it's gonna be 3. Okay. So since it's gonna be 3, so we are going to say B plus C. The first term is 5 there. Then you place 5 here. Okay. you're going to place 5. Then where there's b, you're going to substitute 3. So it's going to be 3 plus c, which is equals to 5. Then make c the subject. 5 minus 3, that will be 2. So your general formula will now be Tn. Remember, it's Bn plus C, the general formula. So your B will be 3n, then your C will be 2. So this is the general formula. You can check, guys. It's very important to check. If I can place 1 here, 3 times 1, it's 2. Plus 3 times 1, it's 3. Plus 3 plus 2, it's 5. 3 times 2 is 6. Plus 2, it's 8. 3 times 3, it's 9. 9 plus 2, it's 11. 3 times 4, it's 12. Plus 12 plus 2, it's 14. So my general formula is correct. Or my end formula. How many squares will be there in 100 term? So you will use your general term, Tn, which is 3n plus 2. Where there is n, you shall place 100. So we are going to have 3 times 100 plus 2. 3 times 100 is 300 plus 2, it's 302. So at position 100, we are going to have 302 squares. That's how we are going to answer such question, right? Okay. Now we will work with question 4. So first thing first, it's a function. So we need to know how to analyze. When we work with functions, you may recall there are linear functions, there are quadratic functions. Yeah, we have different types of functions, but in this case, right, let's work with these functions that involve distances and speed, right? N lives 80 meters away from her friend. She walks to her friend's home and spent few minutes there, and then she walks back home. The graph below shows her journey. Right, let's analyze. So, okay, let's put this into practice. Okay, we will put this into practice so that it will be appealing, guys. So they are saying, how long did it take N to reach her friend's home? Let's see how long. From his initial distance there, oh, it took him from that to reach 80 meters. Let's go. We can see from here that's 5 minutes. So in other words, it took N 5 minutes to go to reach her friend, right? How long did N stay at her friend's home? Okay, let's see. How long N did stay at her friend's home? Okay, that is also easier. You may recall that from here at 8 meters to, let's see, until here. Yes, that's how we are going to analyze this. So in other words, let's see, they're saying for how long did N stay at her friend's? So for how many minutes did N stayed in her friend's home? Let's see. In other words, we have 5 there and we have 15. We have 5 minutes and 15. So we are going to say it's going to be a difference actually. 15 minus 5, that's going to be 10. So in this case, we are going to say 15 minus 5 is going to be 10 minutes. So and did stay 10 minutes. Then now calculate N's average speed in meters per second on her way to home. On her way to home's friend. On her way to her friend's home. Yes, you know, English sometimes may be tedious, but read carefully, guys. So let's put this into practice. Right, guys, let's continue. Calculate N's average speed in meters per second. Right, okay. So to calculate this, you may think of this triangle, DST. Whenever we are working with distance and speed, think of this triangle, DST. So since we are looking for a speed, we are going to close this part. So it's going to be S. Yes, you need to draw this triangle. You will close this part, S, therefore, so that you make it a subject. It will be D all over T. So in this case, it's going to be S D all over T. Speed is equal to distance all over time. So the distance, you may recall, it was 80 meters. Then we need to write time in seconds. You may think of our first question at 4.1. How long did N reach to her friend's home? We will start with that initial time. So remember, it was 5. It was 5 minutes. We need to convert it into seconds. So it's going to be, to convert it into seconds, it's going to be 5 times 60 seconds there. That will be 300. So we are going to have 300 seconds there. So 300 seconds divided 80 divided by 300. Okay, correct to 2 decimal places. That will be 0.27 meters per second, right? That will be 0.27 meters per second. Then we go to 4.4. Show that N's average speed to and from her friend was constant. Well, guys, we are going to use what we got at 4.1.3. Remember that the speed was given as 0.27 meter. We calculated in 4.1.3. So we have to show time. How did we get the time? Remember that I told you it's 5 times 60 seconds. Right. So that will give you 300. So to prove that it was constant, we are going to use the same formula. SD all over T. We are going to do the same thing, but we are going to say 80 divided by 300, which will also give you 0.27 meters per second. So it was constant indeed. We have already proved, we have already shown that it was constant. Yes, we have similar answer here. Right, then we are going to work with 4.2. Consider the equations of linear function given below. So at 4.2.1, we need to write this figure 1 in standard form. So in standard form, we need to make y the subject. So we are going to say 2y plus 4x is equals to 2. Then transpose 4x to the other side is going to be 2 minus 4x. Divide both sides by 2. You'll be left with y. How many times does 2 goes into 2? It goes once. How many times does it goes to 4? It goes twice. So in a standard form, it will be negative 2x plus 1. Then you are done with 4.2.1. Now describe the gradients of I, and you describe, you don't give them the gradients. The first one, we can see the gradient, it's negative. It's a negative slope. For I, it will be, for figure 1, it's going to be negative slope. For that, negative slope. Then the other one will have a positive slope. We can see the gradient is positive here. So it will have a positive, figure 2, it's going to be a positive slope. Positive slope, right? Okay. Now draw and label the graphs on the same set of axes using squared paper provided in Appendix A. Unfortunately, I don't have this graph paper, but I'll show you how we can draw this graph. Yes, and this is where we'll also see how they intersect. Right. Okay, let's put this into practice. All right, guys, remember that we're in 4.2.3, so we need to draw the graph. To draw the graph, you need to have the intercept. For x-intercept, let y be 0. So in this case, we are going to say y is equals to 0, 2x plus 1. Transpose negative 1 to the other side, positive 1, it becomes negative 1. Then when you divide both sides by negative 2, we are going to have x as a half. So this is the first coordinate of x-intercept. So to get the y-intercept, you let x be 0. So meaning that where there is x, we shall place 0. So negative 2 times 0 plus 1, what is that? We get 1, right? So it's going to be 1 when you place 0 here. So the coordinate will be 0 and 1. So let's put it into a Cartesian plane. Remember, you must draw in that graphing paper that they gave you. Very important to do that. So we have 0 0 and 1, suppose it should be here. 0 and 1, it should be here. So we have 0 and 1 here. So what about the x-intercept? This is the y-intercept. What about the x-intercept? It's half and 0. Half and 0. 0. Maybe let's say it's half from here. Okay, then we can see. Use a ruler, guys. Don't be like me. I love rough sketch. Use a ruler. So we have two coordinates here. We have half, also have 0. Okay, so another one, remember another graph that we were given there, it was y is equals to 2x plus 5. So in this case, also the x-intercept, you let y be 0. So we are going to say 0, 2x plus 5, then take 5 to the other side, it becomes negative 5. Then we divide both sides by 2, we are going to have negative 5 all over 2. So this will be the x-intercept, negative 5 all over 2 and 0. So what about the y-intercept? Y-intercept, I said let x be 0. So it's going to be 2, remember? Where there's 0, you place 0 there. Where there's x, you place 0. 2 times 0, it's 5. So it's going to be 5. So it's going to be 0 and 5. Right. So let's figure out the x-intercept there. Remember that we have negative 5 all over 2. So it's negative 2,5. So it's going to be somewhere here. 0. Okay. 0, negative 1, negative 2, negative 2,5, maybe somewhere here. We have negative 2,5, or which is negative 5 all over 2. Right, that's the x-intercept, and sorry for that, and 0. So what about the y-intercept? The y-intercept is somewhere here. 1, 2, 3, 4, 5, it's somewhere here. Okay, so we have 0 and 5. So that will be the graph. The other graph of y is equals to 2x plus 5. For this one, it will be y is equals to negative 2x plus 1. Right? So that's how you can work out the graph part. That's 6 marks. That's how you can work the graph part. Then at 4.2.4, they said write down the coordinates write down the coordinates of the points where the graph cut out the y-axis. Yes. Okay, where they cut out the y-axis. In this case, it will be where it cuts the y-axis. It will be 0 and 1 for the first graph. For the first graph, the other graph, which is Roman figure 1 graph, it will be 0 and 1. Then the other one will be 0 and 5. This is where it cuts the y-axis. It happens here. For the Roman figure 2, for the Roman figure 1 graph, it is 0 and 1. Then they want us to label the point of intersection of the two graphs using the letters A and B, and then write the coordinates. Okay. Okay. Where they intersect, guys, the point of intersection will be here. So we could say A and B, A and B, A or B, it will be here. The point of intersection, this is where they intersect. But they are interested in finding, in labeling finding the coordinates, right? And then you write them. So when they say write the coordinates, this is what you should do, guys. You may recall that we have negative 2x plus 1. That's the first graph. The second graph, we have 2x plus 5. You equate both of them if you want to find the point of intersection. So take 2x to the other side, it becomes negative 4x. Take 1 to the other side, it becomes 5 minus 1, which will be 4. Divide both sides by negative 4, it becomes negative 1. So this will be the x coordinate. To find the y coordinate, just where there is x, substitute negative 1 to find the y coordinate of a point of intersection. So let's say, let's take, for instance, negative 2x plus 1. Where there is x, we shall place negative 1 plus 1. That will give us 3. So we are going to have 3 here. If you take -1 in place here, you're going to get 3. Take -1 in place here, you're going to get -3. So that's how you can work out the point of intersection. Hope you find this video useful, and don't forget to subscribe. Guys, let's subscribe. Let's not watch only. Let's grow this content. Let's grow the community, right? So that we excel in mathematics and we get distinctions, right? So on the 8th of November, 2022, you are going to ace that paper. Trust yourself and put in the work and trust the process. I wish you well. Let's grow the community. Don't forget to subscribe, share, and comment, and like. And remember, we love you.